Hello everyone and welcome to this seminar. In this seminar, we will focus on flood mapping and monitoring using GIS and remote sensing techniques. My name is Kaifi Chomani. I have a master's degree in geomatics engineering, which mainly I focus on using GIS and remote sensing techniques for environmental monitoring and natural hazard assessment. And specifically in this study, I will focus on flood mapping and monitoring. I am a lecturer at the University of Rahman in Iraq. I also wrote and published 5 books about using geospatial technology for different applications in Kurdish language. I published multiple research papers regarding the application of GIS remote sensing. And in this seminar, my main objective is to simply answer 3 questions: why, what, and how. Why, why GIS and remote sensing is important, and why we should focus on flood. And when we focused on flood, what answers we could get when we want to study floods, and to reach this answer, how can we get this answer? So, in simple terms, why flood assessment is important? That's the question that I want to focus at first stage. After that, there's a significant question, actually the most significant question, which is for urban planners and decision makers, uh, which is this: can we exactly know which area will be flooded or not? And actually, this is a very important question to answer. But can we know that actually? We will answer this question. If answer is yes, how can we do that? Which technique is useful? Which technique is um, we can use it for flood in addition the area, flood susceptible areas. And in the last part of this seminar, I will try to give you some examples, some case studies which we studied in the last 5 years, and we will show you. So to answer this and to meet these objectives, I divided my seminar into 4 parts. In part one, I will give you a general insights about GIS and remote sensing, because maybe some of you don't know much about it. I will just give you a brief introduction. After that, I will give you a detailed of using geospatial techniques for flood hazards. So how can we use these techniques? How can we use GIS? How can we use remote sensing? What is the applications of this in flood hazards monitoring? And in the part 3, we will give you some case studies, some examples, and in the final part, I will give you somewhat. We will be there will be a question and answer session that if you have any question, we will answer. For the part one, what is GIS and why GIS is important? Well, actually, GIS is a science which focuses on collecting data, storing or managing data, analyzing data, and visualizing data. And basically, GIS tells you where things are, and it will find the relationship of this data with the geographically another data. So it will you can find patterns using GIS. You can create maps using GIS, and these analysis, these maps, will help you to decide or help you in decision making processes. For example, it will help you to decide which road is better, which road is shortest, which site is most suitable for specific objectives. So GIS is a software actually. There are multiple softwares that you can use for analysis, for data collection, for mapping, for creating mapping, for management data, analyzing data, and visualizing data. But the most, for example, known ones and popular ones are ArcGIS, for example, ArcGIS Pro, which is from supported or created by Esri or QGIS or the platforms that you can use it for these purposes. Actually, GIS is only a tool actually, but for this tool to make it work or to do analysis, well, we need data. So where can we get data? Actually, GIS cannot. Well, at some points, yes, you can create data using GIS, but basically it's not its main objective. Its main objective is using this data, storing, managing this data, analyzing and visualizing this data. But data creation or collection, we need data, and this type of data mainly we depend on remote sensing. Remote sensing is a science of collecting data using, for example, satellites or drones of, airplanes, and these imagery, which mainly we call it images, satellite images. These images for us, for geomatics engineering, for geomatics engineers, these images are data for us. So this is a very significant data which has very important insights about the surface of the Earth or the atmosphere. For example, you can use this data, this satellite imagery, to monitor the land, the water, the weather, and all features on Earth. And because the satellites are orbit around the Earth, and that's why we get multiple images. So using these multiple images, we can track changes over time. For example, we have archived data, for example, in 1917s until now, so we can know what was the urbanization changes or what was the green area changes or how the environment changed in these decades by comparing these images, which are data. And these data really help us to make maps. And we can use this satellite imagery and import it to GIS or the platforms or Python based platforms, so we can, you know, mm, you know, store data, manage data, analyze data, and visualize it and create maps from this data and to better understand it. That's why we need remote sensing. And we combine remote sensing and GIS together to better understand the data, to analyze the data, to find patterns, to find problems, and propose solutions. Actually, one of the significant point and things that we need to consider is that, and we need this actually, if we combine GIS, which is a software thing, and use remote sensing data and combine this also with AI, machine learning and deep learning, then we can get a system and have a system which you can easily identify the problems and also propose solutions for your environmental, problems. So it is very important to us to understand this, the combination of this. So none of these ones alone are, effective enough. But if you combine them together, we can get, you know, a very powerful and comprehensive system to analyze the data, to find the problems, and to have a smarter decision making. So we now the question is this: what can we get if you combine GIS, remote sensing, and AI together for flood hazard mapping and monitoring? What can we get, and what problems that we have will be solved by combining all these three platforms together? And we will answer and focus on this in the future and in this seminar. But before that, let's focus on the second part of the seminar, which is answering this question: why? Why floods? Why we need to focus on flood mapping and monitoring? Well, actually, um, floods are one of the most destructive and destructive natural disasters in worldwide, which have a significant impact on the infrastructure, which caused death of millions and thousands of people in the world and yearly. And unfortunately, in Iraq, the flood events increased significantly in the last decades due to for example, due to the climate change, the environmental, impacts, and also uh, the unplanned or the poorly planned uh, urban places, poorly planned urban areas, poorly planned infrastructure actually, and the main significant floods actually were witnessed in Iraq and in north of Iraq specifically were in 2018, 2022, and 2024. Unfortunately, only in 2080, 50 people died in north of Iraq. More than this is the data only for one flood, which more than 50 people died because of the flood. More than 40 buildings, 150 shops, 860 cars were damaged because of this flood, and it caused $50 million economic loss. Only one flood, one simple flood, which caused damages and loss of lives of specifically in Erbil city. And that's why we need to um, you know investigate these floods, why they happened, why they caused all these damages, and how can we predict future floods, and how can we reduce the impacts and damages of the floods in the future. That's why we need to investigate these floods. Actually, we cannot prevent the occurrence of floods because floods are natural disasters. It will happen again and again. In the past, it was already there were floods, and in the future also there will be more floods. It's a natural thing, but our work is to investigate these floods, to reduce its impacts, to understand its behavior, to understand how can we do something to reduce the risk on human life and also the infrastructure and also the environment to make it less damages. And there are some flood causes. Actually, the causes of the floods it will differ from one place to another because of the natural characteristics, geographic characteristics, environmental characteristics, and design of the city. All these have impact on the flood causes, but generally there are three main causes. The first one is natural causes, which, for example, heavy and irregular rainfall patterns, and climate change, which has a huge impact. But also there are some places which have same heavy rainfall and climate change impact, but due to their geological characteristics, some places may be more affected with floods than other places, which may have same, for example, environmental characteristics or rainfall patterns. And one of the geological causes is poorly drainage systems and rivers. Poorly poor design of drainage systems and rivers, which have a huge impact, and also poorly planned urban expansion, for example, in Erbil city, due to the poorly planned urban expansion between 2003 and 2023. The number of floods were significantly increased in the last 20 years. And another cause is human related, for example, lack of strategic planning, and also dumping waste and garbages into drainage channels, which prevents the natural flow of water, and it will create the flood areas. And actually, sometimes government will do some you know uh, precautions and some frameworks to reduce the impact of the floods, but it's not effective enough actually, at least for urban city, for example. For example, they do cleaning drainage pathways, regular cleaning drainage pathways, and also constructing dams and ponds. But actually, these are not long-term and enough to reduce the impact of the floods. And the second question is this. Now we understand why flood mapping, why we need to investigate floods. Now we understand that it is a significant and deadly, and it's a deadly, phenomenon. So we need to understand it to reduce its impact. So now the question is what? Uh, what I mean here is that what thing is what is the thing that we wanted to know about the flood? For example, if you investigate the flood, what is the question that we wanted to ask? Well, there are four main questions which are useful for us to investigate. The first one is this. It's actually very simple but very important question. Which area will be flooded? That's the main question for urban planners and the decision makers, because we wanted to know which area will be flooded. So it is a future. In the future, which area will be flooded? So why we need to ask this question? Because we want to know which area are susceptible. We want to know what are the problem. What is the problem of this place? We want to know this exactly. So which area will be flooded or inundated or susceptible or vulnerable? All these questions are significant. And the second main question is this: which area is damaged by the flood? Which is it's a past term, so it means there there was a flood, but we wanted to know what was its damages. So this also a significant question. We want to know, we wanted to measure the damage of this flood, which occurred in the past. And also the third question is what is the depth of the flood? So we want to know um, what is the depth of the flood in the past, if there was a flood, or in the future. We wanted to predict the future floods and also the depth of the flood. So these questions are significant. And the fourth question is which buildings are under risk? Actually, it's a very significant question. We not only want to know the area of the flooded region, but we also know which building, exact building. So we want a detailed map of the exact buildings, because it's related to human. It's not just about the bare land area which will be flooded. No, we also want to know which exact building, which people, when they are residents, which they will be, you know, and the risk of the flood. So we want, but so for these four questions, my question now is this: can we know these questions? Can we answer this question? Well, actually, yes, we can answer this question very um, um accurately, but in the later. But yes, we can answer this question. But now the next question is this: if we can know or we can answer this question, how can we answer this question? What is the methodology? What methods that we could use to answer this question? Well, this is the third question, which tells us how can we do this. How? So my question here is now is this: how can we identify the area of the flood? How can we know that? Also, how can we know the depths of the flood? Also, how can we identify which buildings are affected by the flood? So these are the main questions which will focus in the next slides. So just for understanding, I wanna make things very easy to understand, and just an as an overview. So we have before flood and after flood. In before flood, which means we want to predict the future floods. So my focus is here, a future flood. But after flood, which means the flood occurred in the past, we want to analyze it. So before the flood, there are two terms that in literature we mainly use. Actually, there are other terms, but this is the main one. For example, we want flood susceptibility or flood vulnerability or flood risk. So we use these terms to identify which area are susceptible, which area are prone, the possibility of this area which will be flooded in the future. So in this, usually we use the multi-criteria decision making, or AHP, for example, or frequency ratio, or the methodologies that you will use it to identify areas which are susceptible. This is the before the flood. So we predict the flood susceptibility. But we also have another methodology, which is you can identify flood inundation areas. So in the flood inundation, we can know and understand and identify which area will be inundated and what is the depth of this inundation, and also what is the depth of the velocity, or what's the velocity of this flood. So by answering these three questions, we can identify flood inundated area very accurately by using flood simulation techniques. For example, ArcGIS Pro, which has a flood simulation, or HICRAS, or other hydrodynamic or simulation techniques. So all these are prediction for the future floods. But we also have another technique which we use for flood analysis, for example, after the flood events. For example, you have a flooded region. We wanted to know flooded area, so exact, or we can say that real flooded area. It's not an estimation. It's not a simulation. It's not a prediction for the future. It is a damaged area or flooded area mapping for this area. So for this we use one technique which has two methodologies. The first one is using optical remote sensing, which means using satellite imagery, optical satellite imagery. Optical means, for example, RGB. You use the normal satellite imagery, just like a camera that you use. It is red, green, blue. But we also have another methodology which you use radar imagery, which is synthetic aperture radar imagery, and both of them have their limitations and advantages. For example, optical remote sensing usually is for day, but SAR imagery actually can penetrate the cloud and also can work also in the night. So both these techniques, we can identify which area are flooded and also which area are damaged by the flood after the occurrence of the flood. So both techniques, or both for both periods, we can either simulate or predict the future floods, or we can also do damage assessment after the occurrence of the flood. And for the flooded area, so now we want to understand better or do more analysis about this. For the flood area, we have two things, as we said before. The first one is before the flood occurs. So it's a prediction, it's a simulation for the future floods. We wanted to know in the future which area will be flooded or inundated. But after the flood occurs, it is a damage assessment. And before, for the flood before, for the future, which means before the occurrence of the floods in the future, we can use simulation softwares, for example, ArcGIS Pro Flood Simulation, or HICRAS, or flood susceptibility using multi-criteria decision making. For example, these are the examples of the flood simulation softwares. These are simulation techniques. Also this is simulation. But for the flood susceptible areas, we, for example, these are the flood simulation techniques, and these are the examples of the flood simulation. But for the flood susceptible area, which is, for example, the most commonly used one is multi-criteria decision making, which is a technique that evaluates and ranks multiple alternatives, which actually it is based on the multi-criteria. So there are multiple parameters, multiple criteria that are have influence on the flood. So you identify this and create maps for this and give weight for each one of them, and then you get a result based on the overlay analysis. And the most commonly used technique is, for example, is AHP, which you can use for flood susceptibility mapping. This is an example of the flood susceptible areas using multi-criteria decision making and specifically AHP. These are the parameters. These are 12 or 10, 2, 4, 8. This is 8, 12, 40. These are 40 parameters which you consider each one of them, and each one has its weights. For example, this has weight, and which one has more contribution to the flood. So you do overlay analysis for all of this, or weighted overlay, and then you create this map based on this is the result. And this one, the blue areas are flood susceptible areas, very high flood susceptible areas, and you get the results like this. And after the flood, for example, when the flood occurred, so you do want to do damage assessment. So you use optical imagery, which is RGB, for example. For example, Sentinel-2 and Landsat series are optical imagery. But for radar satellite imagery, for example, Sentinel-1 or RadarSat are SAR imagery, or synthetic aperture radar, or radar imagery. And you can use this imagery and process it in GIS or Python-based softwares, or Snap, or the remote sensing softwares, and you can just create this map. Or you can use Google Earth Engine. Actually, it's a cloud computing platform that you can just identify which area is flooded, or where flooded. Actually, it's a past there. And another thing that I want to focus here is the type of the satellite imagery. The orange one is the optical, or sorry, radar satellite imagery. For example, Sentinel-1, Allos Pulsar, and RadarSat. All of them are, these are the characteristics, resolution, revisit time, and also the provider of these satellite imageries, which you can use it in clouded areas, or in day and night. But Landsat 1 to 9 and Sentinel-2 imagery are optical, which provided by NASA and ESA, European Satellite, Europe, and also America and Europe. And also these are resolution, revisit time, and also what can we get from them. For the flood depths, actually we cannot predict by simple methodology. We need to use simulation softwares, For example, ArcGIS Pro, HICRAS, this is our ArcGIS Pro, and this is HICRAS logo. This is the example of the flood depth, and with the legend. The blue ones are 0 to 1 meter, but for example, these near to orange color are, for example, 4 to 5 meters. We can also predict the flood depth. Another question is here, which buildings are under risk? Actually, we can answer this question by doing overlay analysis. If we have the flooded area and flood depths, for example, and flooded area, either after the flood or before the flood, we can overlay this data with building footprints. If you have, we also have building footprints. For example, you can use Microsoft building footprints or OpenStreetMap building footprints, which you can download it, or you can create your own building footprints using deep learning, or you can download it from Google Earth Engine. And by doing overlay analysis, you can identify which buildings are inside the flooded area before the flood or after the flood. Then you can identify these buildings as symbology as buildings at risk. This is the example of flood susceptibility of airable city, and also this is the example of flood inundation map of airable city. The blue area is the flooded area or flood inundated area. It's only a simulation. It's not a after the flood. It's a before the flood. So using ArcGIS Pro Flood simulation, these red dots are historical flood samples, which actually you can see that how accurate is the simulation. Also, this is the flood depths using ArcGIS Pro Flood simulation. For example, the green area flood depths 0.2 to 0.8 meter. The yellow one is 0.1 to 1 meter, and the red one is 1 meter, more than 1 meter, for example. Also, this is an example of the buildings and risk of flood. For example, this is Erbil City. The green buildings are those buildings which are safe during the flood, but the blue one are the flooded area, and the red buildings are those buildings which will be flooded, which are under risk of the flood. So this could be also used as an early warning system that urban planners, decision makers can use this map to go to this place and to find the problem and also propose the solution before the rainfall season. Also, this is another example of the buildings and the risk of the flood, Erbil City. And also, we can identify the number of people and number of buildings also under risk. For example, in Erbil City, 8.2 buildings, 8.2 of total buildings in Erbil City are highly at risk of the flood during, for example, 60 millimeter rainfall intensity. But for the people, more than 7.3% of people, more than 60,000 people, are under risk of the flood in Erbil City, which is actually a huge amount of people, highly at risk of people. So we can actually get this. And this is the simulation which we created for Erbil City by using ArcGIS Pro Flood simulation. These are the 3D map of inundated area and the buildings. The more blue, the darker the blue means the darker the flood, the more flood depths in Erbil City. Also, we can generate a 3D building under risk of flood. For example, in this image, this only an example. The red buildings are those buildings which are very high at risk. The uh, orange ones are high risk. The blue one, the yellow ones are medium risk, and other buildings which are no risk. And we created also a video for this, as you see here. This is the buildings and the risk or at risk of flood, and doing a symbology for it. For example, the red ones are very high at risk of the flood, and the blue areas are flooded areas, for example. You can create this actually, even the simulation, even the video animation are created by using ArcGIS Pro 3.5. And flood barrier actually, uh, another thing that you can do using ArcGIS Pro Flood simulation is that we can do a simulation of putting a barrier in a place which have a flood problem. So even before constructing a real barrier, flood barrier, in a place, we can simulate this to understand if this barrier will solve the problem or not. So the flood barrier is a structure which you build to block or redirect the flood water and protect people, buildings, and infrastructure. And the purpose is to reduce the flow of water and minimize the flood damages. And we actually need these flood barriers. And but the problem is this: we want to know which area need this flood barrier, or which if we put the flood barrier in one place, will it be effective, will it be useful or not? That's the main question that we want to ask. So in ArcGIS Pro Plus simulation, we can actually simulate this. For example, this is the area which the flood will be come to these buildings. So we want to simulate if we put a barrier in this, what will be this? The yellow one is the barrier, for example. What will be the situation? What will be the height? What height needed to be? And what depth and the thickness of this barrier need to be to solve this problem. So we can simulate this also in ArcGIS Pro or other softwares. And as you see here, you can see how the this area now are safe, for example, due to using this flood barrier. Also, we can use flood simulation for or the flow of water simulation for dam breakage, dam failure, and we can understand how failure of a dam will impact the surrounding area. For example, this is an example of in Dukan Dam, which is in north of Iraq, in Kurdistan region of Iraq, in Suleimania Governorate. As you see here, if this dam breaks and by specific flow rate, you can see um, and know which buildings will be under risk, and you can zoom it and identify the buildings under risk and the coverage area of this flood or this uh, flow of water. And you can also use this. And um, also we created a website, a live website, which you can people in every city and decision makers can easily see which buildings and which area are under risk. And we created this, for example, using Google Earth Engine. As you see here, you can easily understand, and this is the legend, which area is under risk, which area will be flooded, and which buildings, exact buildings, are under risk of the flood. So these websites are actually very useful because it's not just for the researchers. For example, we created this result as we did in this research. It will be useless if it will be only inside the paper. So we created a website so people and decision makers can easily go to the website and see by their eyes which area are under risk. Actually, it's useful. And also you can just go to this website. This is the link, and also you can scan this code, and you can just go to this website and see in Erbil city, for example, which area are inundated. And finally, as a resources, I suggest you to go to NASA RSET website, which is a very powerful website which provides trainings and tutorials, the theoretical and practical one, to understand how, for example, floods, we can monitor flooding for English language, and also Esri. This is the website which you can rely on it because it has a powerful tools to flood mapping. And also I suggest using Google Earth Engine, which is a powerful platform to do researches and analyze the satellite imagery. And also you can rely on these two papers which I did some researches, and in the future also I have some papers in review. It's not published yet. um, you can go read these papers which I mentioned in detail how can we do analysis of flood analysis, flood susceptibility mapping, and flood simulation mapping. And this is the LinkedIn. If you have any questions, you can just contact me by email or using LinkedIn. And thank you very much. If you have any question, I will be happy to answer you.